Welcome to CAT Tutorials, and in this video I'll be covering practice problem 7.4. If you haven't subscribed to my channel, please subscribe, and if you like this video, don't hesitate, just click the like button. So let's get right into it. You're given this circuit and we are asked to find I of t for time greater than 0. So this is a switching action which takes place at time equals to 0. Right. So here are a few steps which are highlighted in the textbook and which I'll just revisit so that we're on the same page. So to solve these kind of problems, you first have to find the initial condition. If it's not given to you, then you're going to find RTH with respect to the storage element. Then you're going to find the time constant. After finding all of these, you are going to substitute it into a formula which represents the kind of behavior which you're actually trying to find. So here we're trying to find I of t, which is the circuit response of an RL circuit, right? So let's proceed. We're going to find the initial condition. So now, if you look up here, the switching action takes place, or this is opened at time equals to 0, which means it had been closed for a long time. So for time less than 0, which is the time where it was closed for a long time, we have this in play. And now we have an inductor over here. And an inductor is a short circuit to DC. So this is going to help us to find our initial condition, which is the first step. So at that point, we had a circuit like this. We had our 15 amperes over here. We had that closed. Then we had our 12. We had our 8 over here. We had our 5. Then we had a short circuit at that point. Now that we have a short circuit here, you can see that this 5 is actually in parallel with a short. So a short has a resistor value of 0. So 0 in parallel with 5 will give us 0. So which means this collapses, and this is all we have. And our I is indicated over here. So initial I, which cannot change. So our I just before 0 is equal to our I just after 0, which is going to be our initial condition. So now this circuit is for just before 0. And now we're interested in finding our I, which is going to be our initial condition. So what can we do? There are quite a few ways to actually solve this, but the simplest would be to just do current division. So now let's do that current division. We're going to combine 8 and 24 in parallel so that we can use the current division formula for 2 resistors. So here's what we can do. So 8 in parallel with 24, which is going to amount to 8 multiplied by 24 divided by 8 plus 24. So 8 plus 24, which should be 32. All right. So here, 32, we have 4 if we divide by 8. We have 4, and 4 into 24 is 6. So this is going to be our answer of the parallel combination of these two. So we can just collapse that one and put 6 over here as the result of 24 and 8 in parallel. So now we're interested in finding this I over here. So doing current division, we're going to say I is equal to 15 amperes multiplied by 6 divided by 12 plus 6, which is 18. So 18, we're going to have 3 over there. We're going to have 1. So 3 into 15 is 5. So that is 5 amperes. So initial condition or initial value for I is 5 amperes. So that was the first point on our list. So that is checked out. Next, we're going to find RTH with respect to our storage element. So to do that, we take out all independent sources. We only have one independent source and no dependent sources in sight. Also, we don't really have to do that because we are now looking at a time which is greater than 0. Now at time greater than 0, this is where we actually remove this part of the circuit. As you can see over here, we open this switch and therefore there will be nothing happening on this side. So we're only left with the circuit which is on this side. So we're going to have our 12, we're going to have our 8, we're going to have our 5 over here. And we're interested in finding our RTH with respect to this point where we had our storage element. So if we look at the top part, we have 12 and 8 in series. So 12 plus 8, we have that in series, which is 20, right? So 12 plus 8, we have in series, which is 20. So you have 20 at the top. And then finally, we have 20, which is in parallel with 5. So 20 in parallel with 5, which is going to be our RTH because there's nothing else in the circuit. So 20 in parallel with 5 is going to give us 20 multiplied by 5 divided by 20 plus 5, which is 25. Divide that, we're going to have 5. And here we're going to have 5 into 20, which is 4. So we're going to have 4 amperes as our RTH. So our RTH is 4 amperes, and that is part of our list. So we tick that off as well. So now I have our initial condition of 5 amperes. Then we have our RTH of 4 ohms. Now we're left with finding our time constant, which is the last point. So time constant for an RL circuit is L divided by R. The value of the inductor given to us in the question is 2 henries. So substitute that there, and we substitute our RTH, which is 4 over there. So we have 0.5 seconds as our time constant. So we now have all the variables, or we now have all the values which actually go into the formula for I of t. So I of t is equal to the initial condition, e to the power negative t divided by the time constant in amperes. So now we have our initial condition, which we found to be 5 amperes. We have our time constant, which we found to be 0.5, and then amperes, so the units. So now I can just divide 1 by 0.5, which is going to be 2. And therefore, our I of t is 5e to the negative 2t amperes.